It looks like we are living in the token economy right now. And you know what? Most of your AI bill is for tokens that you never wrote, never read, and often cannot see. These are hidden tokens, and they can account for over 90% of your total cost. And this is the reason why the consumption bill of AI services is exploding these days. It is why services like GitHub Copilot are shifting the pricing models. Technically, the visible part of your interaction with an AI, I mean the prompt you type and the answer you get back, is a tiny fraction of the actual work being done. The real cost is hidden in the background. This video is precisely about those hidden tokens, and by the end you will first understand the 3 types of hidden tokens that secretly inflate the AI cost. Second, you will see how a simple coding task can cost tens of thousands of tokens. And finally, you will learn how to start making this cost visible. So let's dive in. When you use an AI service, you are billed based on the number of tokens you send and receive. And this seems like a simple thing, but it has a big problem. Transformer-based models, I mean the architecture behind LLMs, they are auto-regressive. This means that to predict the next token, they need to see all the previous tokens every single time. When you have a conversation with a chatbot, each time you send the message, the system doesn't just send you the new message. It sends the entire conversation history back to the model. This means the token cost doesn't scale linearly. It scales quadratically. For example, you send 10 tokens prompt, the model gives a 50 token answer, total context is now 60 tokens. Now, you send a new 10 tokens follow-up, and the input sent to the model isn't 10 tokens. It is the previous 60 tokens plus your new 10 tokens. The real input cost is 70 tokens, not 10. The model gives another 50 tokens answer, and the context is now 130 tokens deep. Every time your next prompt will be even more expensive. Do you see the problem here, right? Imagine you are reading a book, but to read the second word on the page, you have to first reread the entire book up to that point. Then you read the third word, you reread the whole book again. I know, it is extremely inefficient, but that's how LLMs work. These replay tokens are the biggest issue, but there are 2 other types of hidden tokens. The second is a scaffold token. These are instructions and metadata added by the agent's framework that you never see. Think of it like the stage crew for a play. The audience just sees the actors, but behind the curtain are directors, lighting crews, and that they set the designs and following a script. Scaffold tokens are that script. System prompts are what says you are a helpful AI assistant. Policy rules that says, for example, do not answer harmful questions and these kind of things. It is basically metadata about the current time, operating system or user. And this can easily add thousands of tokens to every single call you make, and they are completely invisible to you. And by the way, I have made a video about scaffold tokens and harness engineering, so check it out. I will lay you the link in the description down below. Anyways, the third type of hidden tokens is reasoning tokens. Because you see, modern AI agents are designed to think before they answer. They generate an internal monologue, a chain of thought. where they break down the problem, evaluate options, and form a plan. And this whole process, can you guess of what it made of? It is made, of course, of more tokens, sometimes thousands of them. Often you only see a polished summary of this thinking or nothing at all, but you are billed for every single token of that internal monologue. So you have replay tokens from the growing context, scaffold tokens from the system's hidden instructions, and reasoning tokens from the model's hidden thoughts. Now, let's see how this plays out in a real-world scenario. Let's walk through a common task for a coding agent to illustrate this problem. Let's say we want to fix a simple bug. Here is the setup. You have a bug in your authentication code, for instance. Step 1, you query the model. You ask, in this case, the agent, okay, fix the bug in my authentication code. Your query, in this case, is 20 tokens. There is a hidden system prompt, the scaffold tokens, with 5,000 tokens, with a total input to the model of 5,020 tokens. Step 2, then the agent thinks. So in this case, the agent generates a plan. It's internal thoughts. These are the reasoning tokens. Let's say they are like 2,500 output tokens. Step 3, in which there is a tool call to read a file. Then the agent decides it needs to read the login.py file. For example, let's say you are using Python. Then it makes a tool call of 100 output tokens. The system executes the call and dumps the file's context back into the context, in the context window. And the file content, let's say it is 8,000 tokens. Now, for the next step, the model must reread everything. The new input context is the original prompt, in this case 5,020 tokens, plus its thoughts on the chain of thought, which is 2,500 tokens, plus the tool call of 100 tokens, plus the file content of 8,000 tokens, for a total input for the next step. It will be 15,620 tokens. In step 4, it performs more thinking in another file. Here, the agent thinks again based on the file. More thoughts. It could be 2,500 output tokens again. Let's say it decides it also needs to read database.py, another tool call of 100 output tokens, and the second file is content, let's say it is 6,000 tokens. So the context is now even bigger. The input for the next step is the previous context, which was, do you remember? 15,620 tokens, plus the new source, which is, as I say, 2,500 tokens, plus the new tool call of 100 tokens, plus the new file, which is 6,000 tokens, for a total input for the next step of 24,220 tokens. Then let's say there is a step 5, which is the actual fix, in which finally the agent has enough information. It thinks one last time. Let's say it costs 1,500 output tokens. It generates the code patch as a tool call of 1,500 tokens, output tokens in this case, and then the final input prompt contains everything that came before it, costing over 24,000 tokens for just that one step. So we have 3 main rounds in this example of input costing 5,020 token plus 15,620 token plus 24,220 tokens. That is over 44,000 input tokens, plus all the output tokens from SAOs and tools calls, which is another 8,200 tokens. So in conclusion, one simple book fee just costs over 53,000 tokens. And this was just a simple example. I recently created a Python server from scratch, and the total cost was like 2 million input tokens. I mean, easy peasy. And as you can see, this is completely unsustainable. So let's bring this all together. As we have seen, the AI bill that you get at the end of the month isn't high because you are writing long prompts. It is high because your hidden tokens. You have these replay tokens. I mean, the entire history, it is resent every time that you ask a new question or you execute the agent, which, it causes this spiral of cost. Second, you have these Scaffold tokens, which are hidden prompts and metadata, which adds thousands of tokens that you never see. And finally, you have these reasoning tokens. You pay every time the model's entire thought process is executed, not just the final answer. And focusing on optimizing your personal prompts is like trying to save money on a skyscraper by changing the font of the welcoming mat. The real cost is structural. So what can we do about it? Well, I think that we should start by making the invisible visible. Like, for example, you can find the session logs for the AI agent you use. Most of them store traces locally on your machine. You can dig into those files, try to spot the full conversation history being resent, identify the system prompts, and measure the tokens count of file contents being added to the context. You cannot manage what you don't measure. That's what they say. So the best thing we can do is to start measuring and to make sure that we choose the provider who respect the token cost as much as possible. And talking about measuring things, I noticed that the subscribers count of this channel is still in 2 digits only. So if you like this video, click the subscribe button. It helps a lot to this channel. Anyways, thank you very much for watching and see you in the next one. Bye.